The toggle count format, commonly referred to as TCF, is a switching activity file generated during simulation or emulation of a digital design. During functional or gate-level simulation, the simulator observes how often each signal transitions between logic states over a defined capture window. This information is exported into a TCF file and later annotated into power analysis tools to enable accurate estimation of dynamic power consumption. Since dynamic power is directly related to signal switching activity, TCF provides a realistic activity profile rather than relying on assumed or vectorless probabilities. The primary purpose of a TCF file is to capture the number of times a signal toggles during the simulation period. Each toggle represents a 0 to 1 or 1 to 0 transition, and the cumulative toggle count reflects how actively a net or pin is switching under real stimulus. Along with toggle counts, TCF files also record transition probability, or duty cycle, which indicates how long a signal stays at logic high versus logic low. This information is critical because both switching frequency and signal probability influence the charging and discharging of capacitances in CMOS circuits. TCF plays a crucial role in dynamic power estimation, as dynamic power is proportional to switching activity, capacitance, and operating frequency. Power analysis tools correlate the toggle count data from the TCF file with standard cell capacitances, interconnect parasitics, and timing information available in the design database. This correlation enables accurate computation of internal, switching, and net power components. As a result, TCF-based power analysis is significantly more accurate than static or default activity-based estimation methods, especially for data path-intensive and clock-heavy designs. This slide illustrates the typical structure of a TCF file, which is organized as a hierarchical, human-readable text format. The file begins with a header section that defines metadata such as the TCF version, the utility or simulator that generated the file, the tool version, the date of generation, and the simulation duration, along with its time unit. These fields are essential for traceability and ensure that the power analysis tool correctly interprets the activity data within the intended simulation context. The duration and unit fields together define the simulation capture window, for example 10 nanoseconds, over which toggle activity is measured. This is important because toggle counts are meaningful only when normalized against time. Power tools use this duration to convert raw toggle counts into effective switching frequencies. Any mismatch between simulation time and assumed operating conditions can lead to inaccurate power results, which is why these fields are explicitly defined in the TCF structure. The TCF file then mirrors the design hierarchy using scope and instance blocks. Each scope corresponds to a module or hierarchical level in the design, allowing the switching activity to be mapped precisely to the correct nets and pins. Within each instance, the pins section lists individual signals using their fully qualified hierarchical names. For each signal, two values are specified: the signal probability and the toggle count observed during the simulation period. This enables fine-grained power analysis at the pin and net level. Finally, the end of the toggle count section marks the completion of activity data for the design. Power analysis tools parse this information and correlate it with the physical and logical characteristics of the cells to compute dynamic power accurately. By preserving hierarchy and providing explicit toggle and probability data, the TCF format ensures high fidelity between simulated behavior and power estimation results, making it a reliable input for low-power analysis and optimization workflows.